Okay, now we'll talk about the final class of optimizers and some of the most effective. And the first we'll talk about is Adograd. So Adograd has an adaptive learning rate, which is why it's called Adograd, for adaptive grad for gradient. The algorithm decays the learning rate for steep dimensions more than it does for the gentle slopes. This means that it can effectively travel down the steep slopes without overshooting, whilst making good progress on modest values. However, in practice, Adograd shouldn't be used for deep neural networks, unfortunately, because it tends to stop too early. But we can use some of the concepts for Adograd for other optimizers. One of these optimizers is RMS prop. And RMS prop fixes some of the issues that Adograd has, namely by accumulating only the most recent gradients from the most recent iterations. It does, I've made a mistake here, but it does so by exponential decay. It has a tunable parameter, beta or rho, which adjusts this exponential decay, and it's usually set to 0.9. This is the implementation for Keras. Optimizer equals Keras to optimizers, and then we specify RMS prop, its learning rate, and the value for rho. Okay, now finally, or not finally, actually penultimately, we're going to talk about ADAM. And ADAM stands for Adaptive Moment Estimation. And if you read the paper, then you'll know why it's called Adaptive Moment Estimation. And it actually combines the benefits of RMS prop and momentum optimization. So this is the paper if you're interested. The parameters are beta 1 is defaulted for 0.9. And as I've said, the ADAM takes the benefits from RMS prop and momentum. So 0.9, this is the momentum, or beta 1, sorry, is the momentum decay from the momentum-based optimization. And beta 2 is the scaling parameter from RMS prop. And you usually set this to 0.999. This is the implementation for Keras optimizer, and then we specify ADAM, the learning rate, beta 1, beta 2, and then remember this optimizer variable is just then placed inside the compile. Now, okay, finally, one of the best optimizers, NADAM. Now, NADAM is not much different to ADAM at all, actually. And you can just think of NADAM as ADAM, but with the Nesterov added on top. And remember, Nesterov is a way you kind of peek ahead a little bit and compute the gradient for that point. And NADAM actually seems to outperform ADAM a lot of the time, but actually sometimes RMS prop wins overall. So with all of these adaptive optimizers, you might be finding that none of them actually really work. In that case, just try good old plain NAG. Some datasets are just not well suited for adaptive optimizers, although this isn't that common. Okay, the quiz. In general, what is the best optimizer to use for training a neural network? Pause the video and have a think. In general, NADAM is the best and should be used when first building a neural network. If not, switch to either RMS prop, and if that has no result, then NAG. Okay, thank you. See you in the next one.